And this, I don't think anybody in here has written a publication yet for peer review, and if you follow this process, you will get published. It's an algorithm that I've used for years now, and it works literally every time. It starts with doing a proper literature review. And I know that it's sometimes tedious to go through dozens and dozens of papers, but you have to ensure that the project that you're doing has not been done before. And it might be easy if there was only one journal for a specific field, but now there's dozens of journals in this, for, say, covering photovoltaics. There's everything from chemistry and material science journals to mechanical engineering journals to electrical engineering and systems related journals, and all different smatterings of kind of like interrelations between them. And so they're going to be held in different databases. It'll be with different communities that use different types of words to describe the same thing. And if you haven't covered all of those bases, there's a very good chance that your idea, the thing that you're working on, has already been done. If you submit a paper for review and it's already been done, it will be rejected almost certainly by any reviewers in the field that know the literature well enough. And most of the people that are going to be doing the reviewing have been in the field much longer than you have. So they've been doing this for 20 or 30 years. They know the actual people that have done the studies, just not they don't of the studies. And so if you diss their good friend because you're trying to replicate the work that they've already done in the 1980s or last year, you can be assured that your paper will be rejected. So the literature review is the most important part. If you get that right, there's a very good chance that your paper will be published. And so for this class, I expect 50 papers covering the specific topic that you're investigating. And you want to make sure that you've covered both all the way down to get the actual methods that have been used by other research groups, and the breadth to make sure that you're covering every possible topic. And so we covered how to do literature reviews before, so you follow that methodology. Once you've completed the literature review, you're going to choose the details of the experiment that you're going to do. And that experiment can be a physical experiment where you're building something and testing it, where you're making a new material and testing it. It can be a numerical simulation study. It could be a policy type of study. But no matter what you're going to do, whether it's theory or experiment, there's going to be something that you're going to test, a hypothesis that you're going to test, and you're going to write about the hypothesis. So you develop your method of analysis and what you're going to be looking at, and then you give me an outline of that topic and discuss that with me. Now, all of you have sort of a basic idea of what you're going after, but that might change a little bit based on what you find in the literature. If it looks like your particular project wasn't, we didn't finely tune it enough, or someone's done something very similar and you have a different idea of where you could take it a little further, that's what this kind of second step is. Once you have your basic idea gathered, then you want to start the actual paper writing. And in this class, I would like you to try to use either LibreOffice or OpenOffice. Both of them are kind of the open source versions of Word. And the reason that we're doing this is some of the journals don't currently take the new Word format. And what will happen is you put it into their electronic system and then it'll garble it up. And usually where it gets you is the equations. Almost guaranteed they mess that up. And then it becomes very difficult to have it properly reviewed. You end up having to go back into an older version and save it. And if you've ever done this, you know that it turns it into an image. So you lose the kind of visual acuity of your equations. So it's better off just to start with that. And so it starts off with choosing a good journal that's appropriate for your topic. And I maintain a list here in Appropedia that covers the journals that would be sort of most relevant to this class. Some on economics, but most of you are going to be picking a journal in the energy field. Here's all the ones from Elsevier, which is the kind of the top science and engineering publisher, and ones that are specifically related to photovoltaics. And some of the times, some of the work, some of your projects, it might be most appropriate to go after an environmental science or kind of an environmental studies type journal. Now, these numbers that you're seeing after the journal names are its impact factor. And basically, that's sort of a way that the journals are ranked in order to determine how important they are in the field. And so your kind of first tier super journals are your Natures and your Sciences, and they'll have impact factors up at, say, over 30. And those, you really have to have discovered something new in order to be able to get in there, like a fundamentally new type of solar cell that broken efficiency record or something like that would be placed there. Your sort of first tier, hardcore, good, solid journals like Solar Energy Materials and Solar Cells is where you're, taking an existing, say, type of material and you're making it a little bit better and you're making a noted solid improvement on the overall device functioning. Then it would be appropriate for those types of journals. Many of the projects that you're doing would be appropriate for a solar energy or renewable energy. Those are good quality journals, highly read and highly cited, which is how they get the high impact factors. But in general in this class, I'd like everyone to pick a journal with at least an impact factor of 1. And the only time that we make an exception to that is for new journals. And so some of the new journals that just came out in photovoltaics, like I believe the Journal of Photovoltaics doesn't have a rating yet because it's brand new, but it's put out by IEEE. It's going to get an impact factor and it will be solid. So you don't have to worry about that being sort of a poor journal to publish in. Some of them, like Progress in Photovoltaics, have very high impact factors, but in general, because of the size of the field, you're not going to see super large impact factors the way you would say in medicine. Now, in the olden days, and I mean like 5 or 10 years ago, it was even worse, where like a solar energy journal might have an impact factor of 1, and now it's significantly better. So what we're seeing is even in the, if you look at the years, the impact factors are changing, where, journals like Fuel used to be at the top of the pack, and now the renewable energy journals and the solar energy journals are at the top of the pack. More funding is going into these areas, more people are doing research on it, and the more citations. So people are less interested in, say, what you can do with a coal-fired power plant, more interested in putting up a large-scale photovoltaic system. And so you're seeing the sort of the journal rankings increase with what's happening in the overall market. So you want to pick a journal. You want to have it as closely tied to the type of research that you're doing as possible. One of the other things that you want to keep in mind is it's definitely better to write for the specific journal that you're targeting. So yes, all of your projects could probably go to more than half of the journals on that list quite easily. But when you're doing the actual rating, you're going to speak to just one journal. Make sure that you're tying it very closely to their scope and their aims, to if they have a special issue coming out, that's often a good idea. Like if, say for the project that you're working on PVCHP, if there's a special issue on PVCHP, that's a very good possible venue for you to target. And so you choose a journal. You want to have a high impact factor as possible for the work that you're doing. And what that will do is it means that once it's published there, people in the field that are most interested in your area are going to read it, and they'll cite it, and they'll build on it, and then maybe they'll hire you, maybe they'll spin off a company and ask you to be on the board. Like it'll get it out into the field, into the public. And so using LibreOffice or OpenOffice, make an outline. It should be approximately a page long and include the major figures that you are anticipating having in your journal or in your article. So these don't have to be formal. You don't have to like graph them up in MATLAB or anything. You can use just a pencil sketch of sort of what are the main things that you're testing. What's your hypothesis? What control groups are you putting in? What variables are you testing? So that it'll be kind of a basic structural outline of what you hope to do. Don't put a lot of time into the writing of this, just the basic keywords and sort of the general outline of the overall paper. And make sure you contain a link to the journal that you chose. Now, for some of you that are new to the field, you might want to put in a couple journals and maybe let me make the final decision. One of the best ways to choose the journal is in your lit review. If you see the same journal coming up again and again and again, that's probably the best venue for what you're targeting. So then what you're going to get back from me is an extended outline. And so your outline will be around a page. Don't make it too much longer than that. The one that you get back from me will be probably 5 or 6 pages long, and it will contain a lot more information. It'll have the specifics about what the journal needs, what additional types of figures that you have to put in, how the references are supposed to be formatted, all that type of information. All the header information I'll do for you ahead of time because I have a template that I use all the time. And then I'll take, so say your introduction, where you might have a couple bullet points of things that you want to bring in and sort of the flow that you see the paper going. I'll extend that, and I'll put information in there that I may already have. So remember I mentioned that some of the projects that you're doing in this class are built off of former students' work, so I'll put those there in there. And also anything that, we have some standard sort of boilerplate statements that the group says about, say the sustainability of photovoltaics or how the economics is playing out. That's based off of the most recent, say, review article from 2015 on what the levelized cost of electricity of solar is and why it's economically a good idea. So that we already have, and so I'll put that in there. But those will often be highlighted, and so you want to pay attention to the color of the highlights of the things that you're seeing. Anything that's highlighted in gray means that it's lifted directly off of one of our past papers, and because it correlates with what you've done. You cannot leave that gray section in there. Every word, every phrase in that gray section must be changed. That means that I want the ideas in there, but you need to rewrite them in order to make it your own. And what this is doing is cutting down a lot on your kind of extra lit search. So there's the lit search on your specific topic that drills all the way down, but that always has to be put into context. Now, luckily, we already have the context, but you still need to rewrite it. So I don't expect everybody in this class to say, go out and figure out what the levelized cost of electricity of photovoltaics is so that you can add that into the paper to justify the economics. I've already got that done. And so all of you can use that information, but you need to still put it in your own voice. The facts, at least, are still very solid. So all that text needs to be fixed in order to make sure that we don't self-plagiarize. In all cases, in every single sentence, every single thought that you're using that needs a reference, I always want you to go to the original source. And so, you've heard me mention before that Wikipedia is a pretty good place to go if you just need to learn what what the basic definition of something is. You don't quote Wikipedia because that's all secondary sources, none of it's original resource. But you go to the reference list in Wikipedia, go to that reference and read it. And the same goes for academic articles. If Smith said that Johnson said something in 1995, you don't trust Smith. He might have messed it up. He might be misquoting. He might have the wrong reference. Who knows? You go get that Johnson paper from 1985 and you read that and make sure that it says what Smith said. You only ever cite things from the original source, never secondary or tertiary literature. You'll also see kind of highlighted notes to both yourself and the journal. So the red ones are going to be for the journal specifically, and we'll leave the red ones until the very end. And that just reminds me sort of what that particular journal needs. All the journals have different requirements. And the yellow notes are for ourselves. And so it's things like, what the abstract link is, that kind of thing, or something that I want you to do for the next draft. And so the yellow ones are the ones that you should immediately deal with, and the red ones you don't really have to worry about until the very end before they're cut out. Now, so you get this outline back from me, 5 or 6 pages long, and then you want to start filling it in. And you have, having done the literature review, you should have everything that you need in order to finish the introductory section when that literature review is done. With what I'm giving you and the literature search that you're doing, you should have more than enough to complete the literature part, the introductory part. That's where the majority of your citations will be, and it's going to be large. It'll be up over 20 for most of you. Then you go to the methods section of the paper, and that one also should be something that you almost have completed. For the people that are making new devices, that's the only time that your work isn't done yet. So in the methods section, say, of your paper, you're going to have to design the equipment, and actually that's your main deliverable. That would be sort of like the results for the other papers. But for those of you that are doing something else that's more straightforward, where you're following a methodology that's been done before, in that case, you're going to put that method section in. And so again, this should be something that you can write fairly quickly, and you're already pulling that from other articles. The results section is the one that's going to take the most time, because you're going to be doing something new, whether it's building something and testing it, whether it's trying out a new material, whether it's doing some economic analysis, building a simulation. That's going to be the one that you're going to put the most effort into the class, and I don't expect that to come until later in the semester. Do not hyperlink anything within the document. Particularly IEEE can't handle that yet, and so everything has to be hard-coded into the document. So if you're used to doing sort of large, say, industry reports where you've hyperlinked all within it, none of that is going to work. So for this, everything has to be hard-coded. And what that means is when we're dealing with the references, I would say roughly half of the journals use some sort of numbered reference, like a Vancouver reference style. We don't do the references until the very end. have everybody in the class, even if you're, say, writing for the IEEE, you're going to use the Harvard like last name, date, Smith, 1980, and put that in for all your references. And then at the very end, when we're finished going back and forth on the paper, possibly dozens of times, then that last stage is when you go back through and hard code the references to numbers. It takes like half an hour or so. It's a little bit irritating, but the problem is most of the publishers' software can't handle hyperlinked text of any kind. Do not link the figures of the tables in the same way. Most of the journals have you submit the figures and tables separately. For the first couple drafts, if you want to just have everything in, you can have a low resolution figure in it, and that's what we'll do for editing. But in that final version is when you have your really nice high resolution figures following the exact format from the journal. Now we'll talk about figures again in a second. Now that first draft that you send me is the most important one. And you want to try to go through, make sure that your grammar is correct, your spelling is correct. You want to get rid of all the little itty-bitty things first so that I don't have to spend my time that is going to be completely focused on your paper. It should be on the content, not on getting the grammar correct. That said, all of us are continually evolving writers, and you're going to get a lot of feedback from me, and don't take it personal. It happens to everybody. I keep a multicolored mock-up of one of my first papers from my PhD advisor, and this was back in the day before track changes, and he did it with colored pencils and markers and stuff, and it is a work of art. It happens to everybody, and you get better and better at writing this way with time. This is not the way you were taught to write in high school and college. It's much more dry, and one of the ways that you can make sure that your writing is appropriate is that you must make every single one of your sentences defendable. If you follow this rule, you'll be fine. And so how do you defend a sentence? And what that means is that if you say something, if you say a fact, it must be supported in one of three ways. One, the peer-reviewed literature. So after you say a sentence like photovoltaics saves consumers money, after that sentence there better be references. And maybe there's one or maybe there's 10 of them. And the more sort of exotic of a claim you're making, the more important it is to have many references and from good sources. And so if I'm going to say something like all coal-fired power plants in the United States are going to be shut down in the next 20 years, that's a confrontational statement that there's many people that might disagree with it. And so to support a statement like that, I better have lots of support behind it and have lots of economic studies and lots of my own work. Second way is you can support it with previous statements in the article. And so if you've made a couple conclusions, say from your results, and then you say, based on my results, this is true, that's okay because you've supported it, say, with a figure, or you supported it with some sort of simulation. And those can be based off of logic. And so if we say the cost of solar has dropped by half, and that puts it under the cost of coal-fired electricity, then I can conclude based on logic that eventually solar will push coal out of the market. And that's a valid reasoning. So the first way is with a reference. Second way is with a citation. The first way is with a reference or a citation. Second way is with logic. And the third way is based off of your own data. And so every sentence in the article must be supported by one of those three methods. If that is true, then there's really no way that a reviewer can argue with you, even if they don't like you as a person or whatever. Most of you are new to the field, so it's very unlikely that you made too many enemies yet. Some journals allow you to put down a sort of a negative list of reviewers, like a blacklist. So if you, for instance, published a theory that disproved someone else's theory that had lasted 20 years, there's a chance that person might not like you. And so every one of your papers that they review would be rejected. So you can put them on your kind of do not review list. I luckily haven't made that many enemies, or if I've made them, I don't know about them yet, so I don't really ever use that feature. But if any of you, had a falling out with your past advisor or something, that would be someone that would get put on the do not review list. All right. So after you've gone through that first draft, you made sure every one of your statements is backed up. You've gotten your preliminary figures, the basic design of everything in there, then you send it to me. And what I'm going to do, on that first draft, you're writing it yourself. You don't do any track changes. You just write a complete document, make it as complete as you can. But then after that first draft, every version we're going to track changes and send back to each other. And so I'm going to look at your paper. I'm going to edit it heavily with track changes on. I'm going to send it back to you. Do not accept all my changes at once. Go through them one at a time so that you're learning as you go. Like there's a lot of mistakes that people often make. Like you don't use contractions in technical writing. You don't use the first person unless you're very special. So you don't say like I did this. Take yourself out of it and say this was done using this method. There's ways that like I would contract if you're writing, too eloquently. If it's looking like more of a poem than a scientific article, it's going to get squashed. If you're not giving enough details, I'm going to ask for details. And so in that sort of the version that you get back from me, you're going to see red marks all over it for things like compressing the language, and you also see comments. And so what you want to do is, as you're going through it, accept all the changes if you agree with them. There's a chance that maybe I made a mistake, or maybe I didn't understand what you were meaning well enough, and then don't accept that change and put in a comment like, I'm not accepting this change because I found another reference that says this is the way that we should be doing it. And similarly, on all my comments, you have to respond to them. So if I said something like, you need to add 3 more versions of this in order for anybody to trust it, if you add the 3 versions, then you can say done and delete that comment. But otherwise, do not delete my comments unless you've actually made the change. Send everything back to me with your track changes on. So you accept all mine, or don't accept them and make a comment on it. You keep track changes on, make all your changes, and send it back to me. And then you and I are going to be acting as peers. And so I will do the same thing with you. I'll go through each one of your changes, accept them, or leave a comment, and then turn track changes on and make all the edits that need to be done. Now, if you are an excellent writer, we only need to do this maybe 2 or 3 times. A normal, good graduate student, we're looking at maybe doing this 10 times throughout the semester. And it will be, this is an intense practice to be able to get this done by the end of the semester, but you will be able to do it. If you're feeling bad for yourself, like I'm making you do a lot of work, don't be, because I'm doing 10 times more work than you are. So if you want to feel bad for someone, you can feel bad for me. But it's enjoyable work. Hopefully we're going to be getting to a new result that nobody else has ever gotten to before. And that's sort of the exciting part of doing research, is that every one of you is asking a question that no one's asked before, and you're going to know the answer before anyone else in the world. And hopefully it's sort of a positive, sort of exciting answer, and we're going to want to get it out in the literature as fast as possible. So we'll continue doing on this. Now, for 2 of the people in here, you're kind of acting as co-authors on 2 different papers on different parts of it. So the way to do that is every time I send it back to you, all the students act as one entity, and you do 1 edit at a time between the 2 of you and then send it back. So what you never want to happen is you don't want 2 people editing the same document at the same time. You always want it happening serially so no one's wasting time. So if person A corrects the spelling error, you don't want person B to also have to check that same spelling error. You want it fixed by the time it gets to them. But you leave, for me, I want to see the track changes of both students. So the reason for that is if I made a comment like, put in more data here, the first person puts in more data, the second person accepts the change, then I don't see that got actually fixed. It's much more difficult to figure out what's going on. And so the idea here is that it's completely transparent between you and I on exactly what's being done all the time, and that we're backing everything up with references. I'll go back to your Apropedia literature page every time I have a question about something, or if I need to read a paper in depth if I don't understand exactly what you're saying. After we've done that, we're going to repeat this, let's say somewhere between 5 and 10 times usually, until we're happy with the article. And then we're going to send out your articles for kind of an internal friendly review. And so this might be to other faculty members at Michigan Tech that have an expertise in the particular subsystem that you're in. It might be someone else in the class who might just trade. It could be some of the students in my group or some of my former group members that are now CEOs of companies. It'll be someone that's knowledgeable in the field but that didn't participate in the actual paper creation. And the reason that you want to do this, particularly for your first articles, is to make sure that you haven't missed anything. Now, some of your studies, I'm pretty confident that we're going to be on solid ground. I've done papers like this before. I'm already well versed in the literature. For other things, say like the spin coder, I'm not particularly well versed in spin coating technology. And so we're going to want to send it possibly to an engineer at a spin coating company to make sure that we're covered all of our bases, that we're at the state-of-the-art level. For the people that are doing these friendly reviews, we're not going to ask them to correct grammar or anything like that. What we're really asking them to do is to attack the paper, to find errors in it, to find where we've missed something or misunderstood or our method's not correct, and ask them to just write comments. And so they can write comments directly in the paper or just email you back problems, or maybe you sit down and talk with them afterwards, like in office hours if it's a faculty member on campus. After that's been done, you record track changes one more time in order to fix up anything that they had problems with, to add in any more additional information that needed added. And then that's sent to me. I give it that final reread, recheck, and I go through this time the grammar and the punctuation, the spelling very, very carefully to make sure there's not a single mistake. At the same time, I'll also go through the reference list very carefully to make sure there's not a single mistake. To date, there is not a single student I've ever had that has been able to get their reference list correct. Ever. I don't know why this is. It is a little bit irritating. If you use Zotero's export of the bibliography, it goes much better. But there'll always be one or two, and it's something like, like a conference paper or something where it's just weird. So it spits out weird, whether you take it from Google Scholar, it spits out weird from Zotero. But you need to go through line by line and make sure, all the commas and the semicolons are where that particular journal wants them. If you don't do that, you run the risk of, even if the paper is accepted, you're going to get back this really long list of changes that are mandatory. And depending on the journal, and if it's a special issue or something, you might actually miss the special issue if you had to go through this second round of formatting. So, and sometimes the journals kick it before they'll say, these references aren't properly formatted. They won't even look at the paper. So it's very important to do that. I realize that it's tedious. Sometime in the future, we're all going to go to one reference system, and we won't need to worry about this anymore. But for now, you need to go through that carefully. And you can think of it as sort of like an accounting practice of where you're making sure that sort of, how meticulous can you be in your writing. Then you send everything to me in a nice big zip file. And what this will mean is your main document. For journals, say from Elsevier, they're now also making it mandatory that you have a list of highlights. And so these are 85-character long highlights from your article, usually about 5 of them. And the best way to write them is to import your abstract onto a separate document and then cut down your abstract to 5 main points. Make sure you're under that 85 character count. If you're 86 on one of them, they kick the paper back. So you don't want that to happen after you do all this work, for it to sit at the editor's office for who knows how long, maybe a couple weeks, and then for them to send it back to you, because that entire time it wasn't under review. It was just sitting with the kind of associate or assistant editors. And so everything that we're doing, all this rule following, is important because it will get your paper under the eyes of the reviewers faster. And as young people, particularly some of you considering PhDs or becoming professors one day, you want to get as many publications out as you can, have them as in high as impact journals as you can, and kind of make an impact on your field as quickly as possible. And if your paper is getting passed back and forth between you and an assistant editor because of punctuation, that's not helping the world, that's not helping you. So finally, I'll do the cover letter, send everything in, and do the submission, and hopefully you'll hear back soon that the paper was accepted. In rare occurrences, the paper will be accepted almost immediately. This has happened to me a couple times where the reviewers just say, fantastic work, publish as is. Usually they have a couple minor points that they want better explanation of, or they want you to add a little bit more literature to support a certain point. And I would say that would happen in the majority of the class, and then there'll be a few of you in here that just get unlucky and you get tedious reviewers that will want something very significant more. Like maybe you did simulations and you ran your sensitivity over kind of 1 to 100. They'll ask for a sensitivity range of 1 to 1,000. And that means at that point we need to decide whether it's worth it to do a lot of extra work to be able to give the reviewers what they want for that particular journal, or whether we maybe go to a smaller publication that would accept sort of the semester level of product. In other rare occasions, if it does look like there's significantly more work, and let's say you've graduated by this time, I'll pass that on to the next sort of wave of students and have them complete your work. And so any of the work that you do in this class, you will be published on, hopefully all of you as first authors, but if it doesn't make that first round of review and it needs something else special, then the next wave of students would hopefully get you in the literature as well. But in general, if you follow this methodology, you will publish. And it will be at a pretty decent journal. It'll be a good first step, like a good getting your foot in the door.